Welcome everyone. Thank you for joining me in this breakout segment where we encourage active audience participation and you can ask questions directly. A little housekeeping before we begin. Please feel free to post your questions in the Q&A section. If you face any technical issues, please post a private message to our SingX help team using the chat function and someone will attend to you. Joining me today is Akansha Jagwani, CEO and co-founder of Sixth Sense Private Limited. The topic for this session is transforming capabilities with AI-powered insights. We will be touching on what it means to deploy and harness AI in the context of semicon manufacturing, how Sixth Sense have applied deep learning techniques to enhance defect detection, and the journey of some of their clients have undergone to get on board. Akansha, I am excited to jump straight into the topic. Perhaps you can begin by giving a 1-minute overview of what Sixth Sense does and a key value proposition of the AI-powered defect detection.
Sure. Thanks, Darren. It's a pleasure to share with you all. Sixth Sense augments the decade-old traditional techniques for defect identification with more robust and adaptive software that is based on deep learning and computer vision. Our first AI, Classif AI, helps manufacturers automatically analyze their visual inspection data to identify if there is a defect, and if there is, it recommends a defect class. This makes the whole defect review and classification process more consistent, accurate, detailed, and 24/7 reliable. We also help manufacturers connect the analysis across multiple inline and final inspection stations to learn at a very macro level about their product's quality. So in a nutshell, this is about Sixth Sense.
Okay, so in your opinion, would you say these AI deep learning techniques are here to complement or perhaps even replace traditional defect detection methods in the fab? You know, what is the current situation like and what can we expect in the future coming forward?
Cool. The tricky one. So we are trying to discuss if it's going to replace the systems or is it going to complement them?
Correct, yes.
I would say whatever is correct from first principles of logic, it would stay and AI would complement it further. An example would be, let's say it will complement the data acquisition systems and maybe replace the rule-based approach of processing and decision-making. Another example would be that it will replace the human's tedious work on sourcing, tracing, and mapping the data from multiple stations. But it will help in accelerating the zooming in process to narrow down the root cause of the problem. So long answer short, I think it would do both. It depends on where we are applying AI and what is the system before that.
Right. Thanks for clarifying on that, Akansha. I think continuing along this topic, right, we all know that defects in the semiconductor processes can limit the yield, increase overall production costs, and also lead to time-dependent critical component failures. So this particular portion, right, and you're saying how AI could help in this defect detection. Could you share exactly how and where AI can be applied in the semicon process? And what benefits could one hope to achieve versus your traditional defect detection methods and how it could complement these methods?
Cool. So what I can do, Darren, here is that I'll first of all share about the broad spectrum wherein AI can be applied in the whole semicon process. And then maybe next I'll dive deeper into sharing the benefits of implementing it as opposed to defect detection systems today. So where can AI be applied? I think fundamentally AI is nothing but a very reliable brain who you can delegate your critical decision making. So now we can start with very small siloed delegations like AI, help me classify defects at wire bonding stations. Help me bin at wafer sorting stations. And if AI does a good job there, we can delegate AI to connect decisions made at siloed stations. So this is like a very broad thought process behind where and how can AI be applied. And this concept can be extended to delegate AI to to help you predict line yields as one of the applications, electrical performance at multiple stations. It can even help you with improving optical proximity corrections sometimes. It depends on how you are assessing the need and implementing AI in that case. Coming to the aspects of high value assets, it can help you understand when to maintain an equipment and not make it a periodic maintenance process. Given in the COVID situation, I think it's very essential to understand where to implement our human resources, the most valuable human resources, and make majority of mundane work automated. So I would see like there are a lot of work like John was mentioning in the previous session on scheduling. So looking at preemptive scheduling and planning processes from AI's mindset. Um, where else can it be applied? I think one of the very recent applications I've seen of AI is tracking your operators' actions and assisting them improve the performance and learn from their own experiences and patterns. So I think this is in a nutshell where all AI could be applied. Darren, do you think any other things where we see in the semicon process where we can add more value?
Yes, I think throughout the semicon process itself, AI has a very much complementary and enabling role to play.
Right.
Okay. So I noticed we have some questions from our audience. So maybe I'll pose it to you. So does Sixth Sense have any case studies to share? And what makes Sixth Sense approach unique in this whole realm of AI implementation for defect detection?
Sure. So maybe I can share on the case studies from our current manufacturing companies that we are working with. May I know from the audience if they would be more interested to learn more about applications and front-end fabs, or is the audience more interested in understanding about packaging side of manufacturing? Or I could share both, whatever is more convenient.
Yeah, Akansha, why don't you share both? I'm sure everybody will be interested to know the possible applications and the benefits that results from these methods.
Done. So let me start with the front-end fabs. One of the use cases that we are solving is automating the review of optical and SEM defect images that are collected in the inline inspection stations in a fab. So the problem statement is that currently visual defect review and classification is conducted 24/7 by highly trained human operators who closely examine images through the naked eye. And as chip sizes are continuing to shrink, manufacturing complexity is sharply increasing. This is making the whole defect identification process extremely challenging. Here, how have we applied AI is we have helped them automate the repetitive and cognitive challenging process. And ultimately, they have received benefits in terms of reducing the misclassifications, reducing the dependency on human judgments. And also this is helping them preserve their valuable domain knowledge and adding more consistency to the process. So this is one of the examples from front-end fabs where AI has helped make their journey more easy and more consistent.
Okay.
From the backend side, from the packaging side, I can share another example. Here, there are rule-based machines, AOI machines, automated optical inspection machines, which are working at the final inspection stations, helping manufacturers decide if a unit has to be rejected or shipped to the customer. Sometimes there are high errors in differentiating between minor deviations, and manufacturers are facing yield loss due to false rejections today. So the other problem that they mentioned was that there is a very unpredictable delay as extra lots have to start to compensate for the rejected yield losses here. And by implementing the Sixth Senses AI technology, manufacturer was able to mitigate this as a learning-based system had learned the subtle variations and it was less sensitive to the defects next time. This ultimately lowered their false rejection rates and manufacturers were able to decide the lot disposition more accurately. So this is an example from backend of manufacturing where Sixth Senses AI helped them in better decision making.
Right. Thank you for sharing that, Akansha. Okay, it's a little bit technical for me, so I don't know whether this has already been covered in what you just shared. did what you mentioned, the use case you mentioned, cover this area of wafer inspection?
Yeah. So basically the first use case was on wafer inspection. Typically today, there are wafer scan stations in front-end line where they are scanning a wafer. And after that, there are review stations where they are trying to manually classify the defects. And we are trying to help them automate that particular process.
Right. Okay. Thank you for that. Let's maybe switch gears a little bit and answer the other question coming from our audience here. And I think all technology, AI or otherwise, has certain limitations. This perhaps coming from the angle of the workforce, in what way do you think AI could, and I use the term very loosely here, harm or be a danger to those workforce or staff not so technically inclined in this area of AI, doesn't have the knowledge or the skills to implement this kind of system? What do you think is the impact then to the workers in the fab, from the ground level engineers and perhaps even to the managers overseeing the fab line?
Sure, Darren. I think the idea is to understand if they're going to be impacted, where can they find the next location. So there is always a place for doing more creative and eventful work. And this is where the current companies that we are working with, they are trying to find a proper roadmap to basically upskill these workers and put them into place where they enjoy the work more. We have had first-hand experience talking with operators where they feel like the current work is so mundane, so repetitive that it doesn't feel so exciting to do on a regular basis. So I think as a human, we are very creative, and figuring out ways where you can add more value is what all very important. And I'm seeing the government here and also the companies putting in a lot of effort to figure out the right next place for these workers once AI helps them automate the processes.
Right. So it seems like the workers don't have to be so worried about their job,
Right.
right? Yeah, and it's really there to help them. The AI is there to help them and not basically to take away their jobs.
Absolutely right.
Okay, shifting gears a little bit, more quantifiable kind of benefits angle, right? What is the average improvement of the yield after implementing AI solutions on, let's say, wafer inspection?
Sure. I think giving out a number saying yield improvement X percentage is hard, but what we can see is where is AI applied in the whole manufacturing operation. So first of all, if we are applying the AI in making the human decisions automation at the inline stations, we can first of all understand how does it translate to less wafer scraps at the end of the line, and also help you with lesser line stops in between the lines. So I think in terms of yield, it would be one parameter to consider, but there are more parameters to look into the holistic picture. And the ultimate impact, like the starting point is how can you reduce misclassifications if we were to talk about the use case that I was mentioning just earlier. So when we talk about that, we have seen significant reduction in misclassifications. Well, it depends on the baseline that the company is operating at currently. If the company has current classification accuracies when humans are doing it, and they have put in an extra effort to create a system around tracking the performance today, the accuracy numbers were close to 70 to 80%. And with AI-based classification, the number of classification accuracy improved to above 90%. But ultimately, it is a function of your manufacturing floor, your data, and your operators. We have to look into that from that perspective. There is no absolute number that can be told here.
Right. And I say it may not be so immediately quantifiable, to quantify the success. But then, okay, then even if it's not quantifiable, intangible, or what do you think, from your opinion, would be a successful implementation of AI in a wafer fab operations, right? What, in your engagement with your clients and the case studies you see in your experience, what do you think or do you consider is a successful implementation of AI? What are some of the things that in your mind would be considered successful, basically?
Sure. So Darren, I think it is about that AI can be quantified. The performance can be very much quantified. It is about have you placed systems in place that are helping you track those parameters very well. Because as with any data analysis problem, whatever data is presented will help you make decisions based on that. So in order to quantify if AI is adding enough value to your operations today or not, it is important to set up a baseline first of all, and from there on go on to tracking that. So I think I have seen companies tracking that in terms of their cycle time. They're trying to understand what was the number of line stops that was happening before AI was implemented and how did it reduce significantly. This track has helped them understand that. So basically, when we work with companies, we work at two stages. First of all, we show them and demonstrate them the technical feasibility of a use case. And second is the stage wherein once the technical feasibility has a green check, they go on to measuring the ROI of such projects. And in both the scenarios, the matrices that they use and the amount of effort they put are quite different.
I see. So I think from what I can gather is that the companies determine the success factors based on their own priorities, and or like what you mentioned, line stops could be one quantifiable measure, right? Okay, that's good. Okay, so I have another question here. I think it's interesting from the audience, right? I'll just read it out since I think it's a little bit above my technical knowledge. So hopefully it still makes sense to you. Okay. So this question is regarding third optical inspection process. Is it a 2D or 3D inspection? And what is the overkill or underkill %? So I hope it makes sense to you, but for me, yeah.
I would like to get a clarification on third optical inspection process. What I have gathered is that when you have a package or a wafer which you are trying to inspect, you can inspect multiple surfaces and of that particular unit, and also you can inspect it multiple times. So typically companies have a inspection process in which there is a station 1 which is doing inspection of all the units, and then they have a second check which humans do today. So I'm just trying to understand, is the third optical inspection process like a third check to inspect the same unit, or is it meaning something else?
I think let's go with the assumption that yes, it is the former what you mentioned and answer it that way. Yeah.
Got it. So I think this was a very interesting use case that we were solving with a company in Singapore, in which we were trying to understand what was the overkill before applying 6sense for that particular package, and how did it significantly reduced in terms of the overkill. The false rejections were significantly reduced. So basically, they had a package, a LED package, which they were trying to understand. And well, I can't share the exact numbers of the company, but it was close to 20% overkill save that they were able to achieve by using AI-based inspection as opposed to rule-based inspection. I hope I answered the question from the audience in that.
Okay, thank you for that, Akansha. Oh, yeah, it seems this is a very hot topic because we are getting a lot of questions from the audience, which is good. And we have good audience engagement. So the next question here, right? Can AI be used for election mechanism process? What is the state?
Election mechanism process.
Yeah. Okay, so
I think I don't quite get the election mechanism process.
Right.
I'm so sorry for that.
Yeah, sure. There's no issue. I think I may be reading it incorrectly. Never mind, it's okay. Let's go to another question here. So in your opinion, to what extent do these AI-driven methods fit with manufacturers' existing capabilities? Those companies have engaged so far and looking at the current state of the industry, does it tend to be a big leap for most of them to adopt this kind of AI-driven methods for the defect detection, or is it more like a small accessible step which they can take?
Sure. I think a lot of this depends on the mindset of the company and the scale of the project that they are trying to achieve here. So once these two are in place, Nothing is a big leap. Everything is a small accessible step because they have thought through the process. They have put right milestones in place to keep tracking it. And once they're measuring something, they're seeing the benefits and then they're taking the next step. So I think a lot of it depends on the groundwork that is already completed and what support systems are already available. It also depends on the scale of the use case here. For example, most of our clients had a very clear problem definition of what they wanted to achieve, and they had set teams inside their companies who would help us gather data, who would help us clean the data. And that is where it just felt like a step change, because all they had to do was now have the brain inside the company to solve the problem for them. But there were companies who did not have a right data collection system in place, a right traceability system in place, and because of which they had to wait for a couple of months to start implementing the AI solutions. But as long as you have the right mindset, the right leadership team inside the company, it's quite possible to make it a step change as opposed to a leap big change.
Right. Okay. I think that puts it into a good perspective. And a related question, I think. You mentioned that definitely they need to have the data collection and all this in place, but perhaps now is a good chance to share with our audience, right? To give them a better sense of how they can start the journey of integrating AI into the existing production. What are basically the first, you mentioned they are small, they can take small baby steps, you know, to get on this train basically. So what are the steps or these small steps they can take towards starting this journey of integrating AI and of course enjoying the benefits of AI implementation?
Right. Thank you, Darren. This is a very great question. The most important thing, like I said earlier, was the mindset to transform. Having a collaborative mindset is just very important, and it just makes the journey very easy. The train that you were trying to catch would become just very smooth because you have thought about it. And after that, I would say once the leader has a mindset, the leader should set up a team of champions, of managers and engineers inside the company, and who should propose multiple problem statements. And based on the overall business objectives, they can prioritize which problem statement to integrate AI in. I think from there on, it becomes more of an execution strategy in the journey. In addition to prioritizing the business problem statement, some other points that I would highlight that they should consider in the whole journey would be picking a use case that is easier to validate and that is easier to win everybody's confidence inside the company that their effort was worth it. I think that's a very small stepping stone that is very important to be set up right in place in the first few months. Once you have a win-win situation, next I would recommend would be to check if supporting systems, like I was mentioning, data acquisition systems, storage systems are in place. And lastly, any successful implementation is also a function of feeding the right quality data into the AI while it's learning. And I feel like no better than the internal engineering team can understand their nuances of manufacturing processes and make this a successful implementation. So three things: having a proper business objective of implementing something, having the systems in place, and having the right team to implement such projects. I think if all three are in place, this could be a very great project for the company.
Right, thank you, Akansha. I think what you shared basically gave an idea that it's not impossible or that difficult to start on this journey, and in fact, accessible to companies both large and small.
Yeah.
Okay, I'm afraid, unfortunately, we are getting close to time, so we'll have to wrap up. Okay, I want to thank you, Akansha, for joining us today and sharing your perspective and insights. It was very interesting and engaging. Okay. For our audience, if you didn't have a chance to get your question answered, don't worry, you still have a chance to ask Akansha by joining our Interchange community platform, where you can post comments, interact with your fellow participants, and participate in discussions. Information on joining Interchange is shown in the chat room and in an email that you will receive after this session. Also, please take a moment to provide feedback on this session and do let us know if you have ideas for future topics. So you'll see the poll coming up on your screen now. Okay, your feedback will help us make future sessions even more interesting and engaging. A link of today's entire webinar will also be posted on ITAP Connect's website, so you can review what was being discussed and mentioned today. Once again, I would like to thank everybody for joining us today. We look forward to seeing you at Interchange and having you join us in future episodes.